Okay, so we left just before this. Now we have the capacitors. यहाँ पे हम क्या स्टडी कर रहे हैं? हम स्टडी कर रहे हैं कि what's a capacitor and how does it work and what kind of types does it have. So basically, capacitor is any device that can store charge. That's literally it. There's nothing more to it. The actual complexity for capacitors is how they are made, because there are dozens of methods you could create a capacitor, because हर तरीका जिससे आप charge store कर सकें anyway, then you have basically made a capacitor. So उसके लिए you have organic methods, you can use chemicals, you can use different materials. For example, यहाँ पे हमारे पास parallel plates हैं, and they are conducting plates. Obviously, if they are conducting, otherwise they won't be able to store the charge. So उनका जो उनकी सबसे basic formation है वो ये होती है कि there are two, or like there are some uh, conducting materials. It could be two, it could be more than two, and there is insulation between them that allows, or actually doesn't allow, the charge to flow to the other body. So इस example में भी, if we could see that there's this insulation space which doesn't allow the charge to go to the other space, and this basically I was saying this allows the capacitance to happen. तो कि ये जो इसके अंदर ये चार्ज स्टोर रहता है ना, उसकी वजह यह स्टोर रहने की कि यहाँ बीच में इंसुलेशन है. So it wants to go to that way. See, they both charge from both sides wants to go to the other side somehow. This wants to jump, this wants to go like this, but we're not allowing it to go. We cut it from here and here. So basically both रास्ते जब कट जाते हैं तो उसको चार्ज को stored रहना पड़ता है उस surface पे, and this basically allows the capacitance to happen. अब इसके लिए हम कहते हैं कि भाई charge is directly proportional to the potential difference, and then we say is because it's directly proportional, so that we introduce the constant capacitance. Capacitance is given by charge over potential difference. This tells us the lesser the potential difference and higher the charge, the more the capacitance. So remember this, jitna potential difference kam hoga, okay? So we don't want कि एक साइड पे चार्ज ज़्यादा हो एक साइड पे कम हो. यही होता है ना पोटेंशियल डिफरेंस. मैंने आपको पहले थोड़े पहले समझाया है that we don't want there to be a difference in the charge. We actually want there to be as less of difference as there could be. And above, we want, in the numerator, we want a lot of charges. We want as many charges as possible to be stored on this surface and the hair as well. दोनों तरफ ज़्यादा से ज़्यादा हम चाहते हैं कि और उनका डिफरेंस कम ना हो, तो हमारी कैपेसिटेंस खुद ब खुद बढ़ जाएगी. With that in mind, we will study its types now. So there's parallel plate capacitors. We say that C is equal to Q over V, and we say E is equal to V over D. We already know this. We studied in where potential gradient. And this we already know is the charge density, charge over area. Uh, and what else? Oh, by the way, this charge density is for per unit area. Because here we don't have a volume to exist, it's just area, क्योंकि ये दो plates ऐसे करके पड़ी हुई हैं, so इनका सिर्फ area हो सकता है, they do not have any volumes. Okay, then we say कि um, we say that charge charge density over permittivity of free space. We remember this was the value of what? This was the value of electric electric field, right? The intensity. So intensity is defined by potential gradient and Q over A into what do you want to call it, permittivity of free space. And this this gives us another relation for the capacitance of a capacitor. What else? Oh yeah. So if they are of different materials, so we could just put, instead of this one permittivity, we would just put two permittivities, and this would give the capacitance. And on the last page we have oops. On the last page we have okay. So here we're saying the positively charged attracts the negative end of the molecular dipole. So it's basically explaining it on atomic level कि क्या हो रहा होता है basically. uh, Pulling, बहुत सारी pulling है, because electrons want to flow but they're not being allowed to flow, उनको आपने basically trap कर दिया, and this creates a polarization होती है जब सारे रास्ते में या किसी भी मीडियम में, किसी भी मटेरियल में जो एटम्स हैं, the electrons and the protons, they are pushed on the two ends. So polarization का मतलब है कि दो poles है ना basically. You are creating, you're getting two poles. See, one, if you want to call it one and one south, so you're getting two poles. So instead you're creating positive and negative poles, right? So this this creates poles, and this phenomena is called polarization, and this is like a direct consequence of what, by holding positively charged body and negative charged body, uh, and inserting a medium between it. Even if it is an insulator, this polarization still happens but to a lesser degree. Then we have energy stored in a capacitor. So we want to know how much energy is stored in a capacitor. We say the average potential. Okay, for first it was zero, and then it's V, so it's basically half V. Potential difference we found 1/2 QE, because we remember it's the potential energy is given by charge into potential difference. So then you have energy is equal to 1/2 CV square. So what did we do? We put the value of Q. Q was CV, if you remember. C was C was Q over V, right? So Q is equal to CV, and we put CV here, and this gives us CV square, and this gives us the energy that a capacitor can hold. And yeah, that's pretty much it. Uh, yeah, that's pretty much it. So you can just mess around with the formulas. And here I wrote some notes that when charging a capacitor and while discharging a capacitor, you have this phenomenon that the voltage is greater than the electric field, and when discharging is the it is greater electric field is greater than the voltage being discharged. So these are some notes I wrote in my own days, and you can use them for your own understanding if you want. And that pretty much concludes the electrostatics chapter. If you have any questions, you're free to ask.